In this session, you're going to be learning about uniformly accelerated motion. As a student, learning about UAN, uniformly accelerated motion, will afford you the foundation for everything from engineering dynamics to understanding how objects move in everyday life. What happens when something speeds up at a steady rate? Think of a car leaving a stoplight or a ball rolling down a hill. These are examples of uniformly accelerated motion. See you in the lesson proper. Once again, students, you're welcome to this section. We are going to be looking at full application for uniformly accelerated motion. Again, we are going to be drawing knowledge from our previous studies, and that was the session based on derivation of formula on uniformly accelerated motion. Again, you could recall that we did have that one. We had one v equal to u plus at. Then two, we have s equal to ut plus half at squared, or half 3 of v squared equals to u squared plus 2ax. Now, for proper application of formulas, we're going to do something here. We are going to group these formulas into the various types of motion so that we can find it very easy to apply the formula in solving problems. Let's do that. Now, we're going to group this formula into what? Into 3 sections. Now, first of all, we'll classify this as this first set of formula derived. We're going to classify them as horizontal motion, horizontal motion, and here we're going to classify this as vertical downward, downward motion, vertical downward motion, G, vertical downward motion. Let's take it as one vertical downward motion. So vertical downward motion G. Here we're going to have vertical upward motion minus G. So we have had here that here we have, okay, our first question is here is number 1, v equals to u plus 80. U plus 80. Here, for vertical downward motion, is going to be v is equal to u plus gt. I'm going to explain why is u plus what gt. Here, for vertical downward motion, is motion under gravity. It's motion under gravity. Here, for motion under gravity, some motion is influenced by what? Acceleration due to what? Gravity. So while also for vertical upward motion also influenced by gravity, such motion, the body is working against gravity, acting against gravity. So here is what? Minus g. But let us write the equations here. We have here also our s become what? H. Our s become what? H. Why does it become what? H? Now, here for horizontal motion is simply what? A motion of what? A body. For example, we have a body moving from point A to B at move 2 meters. This horizontal motion influenced by what? Acceleration due to gravity. Acceleration A for horizontal motion. But if this same body is moving without the body touching the ground, such a body, when it's what? Moving downward, our s, the same distance that is 2 meters here, if we move 2 meters, we no longer call it s, we call it what? H, because it's a vertical distance. It's a vertical what? Distance in 2 meters. But here, when the body was touching ground, like a car, for example, it was 2 meters here. But like an aeroplane moving at the height, or a stone that is thrown at the height, so it should be what? H. So we're going to write here that s becomes what? H. H equal to ut plus half gt squared. Ut plus half gt squared. Here also we have v squared. V squared is equal to u squared plus 2gh. So that is that. So we are here translated from horizontal motion influenced by acceleration A into motion under gravity for vertical downward v equal to u plus gt. Here A equal to ut plus half gt squared. Here we have v squared equal to u squared plus 2gh. But motion under gravity, here the body is falling downward. When the body is acting against gravity, this same equation becomes v equals to u minus gt. Here also here h is equal to ut minus half gt squared. Also we have here v squared is equal to u squared minus 2gh. So we have gotten the three sets of equations for a body moving horizontally with the legs touching the ground, for a car moving on the road influenced by our acceleration, uniformly accelerated motion. Here also a body falling down. So our equation translates to this: a body acting against gravity, a body that is thrown up. The equation translates to this set of equations. Now we are going to take example. We are going to take what example? Here already there's an example on the board for us to interpret what this equation. That's why we said formula application for uniformly accelerated motion. So first of all, we have been able to group the equation. So let's see it applied here. Now this is example one. Example one, we are told that here a ball dropped from rest falls. A ball dropped from rest falls freely to the ground. Find the position of the ball after 2 seconds. So how do we solve this problem? Now, in solving this problem, the first thing you have to recognize here is what type of motion. Is it a motion? Is it a horizontal motion here, or vertically downward motion, or vertically upward motion? Now, from the question here, we say a ball dropped from rest, falls freely to the ground. Find the position of the motion. From the word dropped from rest means that the body was dropped from what? From rest. It's like a mango seed attached to what? The branch of a mango tree. If such a mango is dropping from that height, it must be what? Such a motion we can classify as vertically downward motion. It means that here we have identified the type of motion, whether it's what? Motion under gravity or just motion influenced by what? Acceleration. So I will identify the type of motion, then we come here and also identify the formula. Before we identify the formula, we are going to bring out the parameters. A ball dropped from rest. There we have u is equal to 0 meter per second. Here we're talking about what? Rest. Body was dropped from rest. I will identify it. Then freely to the ground. We are asked to find the position. Here, position stands for distance. And because the body is dropped from a height, the type of position here is what? H. So we are interested in H. And also, it says find the position of what? The ball after 2 seconds. So we are giving that T is equal to what? 2 seconds. Output time, 2 seconds. Output time in this type of motion, G will always be given as 9.8 meter per second squared. So this acceleration due to gravity is a constant. So it's a constant. Its acceleration to gravity is a constant. We have here solution. So G will always be given. So now we have G equals to what? 9.8 meter per second squared. Now haven't gotten our parameter to be what? U, H, T, and G. So we come here. Now we can see that from here, we see that what three things now have U, H, T, and G. V equals to U plus GT. That one doesn't fit in. H equals to UT plus RGT squared. Here we have that. So we take the second equation, which is our H equals to UT plus half GT squared. So we put the parameters. Here our H is what we are interested in. U is what? 0 times T2 plus, here we have half times G is what? 9.8 times, here our T, here our T is what? Our T, this is what? 2 squared. So we have here H is equal to 0 times 6 was 0 plus half times 9.8 times 2 squared is what? 4. 2 squared is what? 4. So that is that. So if 2 squared is 4, now we can resolve directly. So if 2 here cancel our 4, we are left with what? 2. We are left with what? 2. So here we have our expression will now read 0 plus 9.8 times what? 2. And that will teach you what? 19.6. So we multiply these two, now 19.6. Unit is what? In meter. So 19.6 what? Meter. So that's example 1. That's what example 1. We've applied that. So right here, we're also going right now to apply this formula to example 2. So in our example 2, here we see that we are told that a car is uniformly retarded and brought to rest from a velocity of 36 km per hour in 5 seconds. We have to calculate 1, the retardation, 2, the distance covered during the motion. Again, let's apply. Now, in order for us to solve this problem, we have to identify what type of motion. Now, identifying this, we see that this type of motion here is based here. A car will usually move on the horizontal road. So this is not motion under gravity. So we are going to choose our formula from here. From V equals to U plus AT, S equals to UT plus half AT squared, then V squared equals to U squared plus 2AX. Now, say a car is uniformly retarded and brought to rest. For a retarded motion or a retardation motion, V is equal to what? 0. Our final velocity usually was 0 meter per second when it is what? Retardation. So note that V is 0. And we are told that it was brought to rest from a velocity of, so our initial velocity U now is what? 36 km per hour. Now we have a job to do here. Now, you see our initial retarded velocity was what? 0 meter per second. And our time t here is what? 5 seconds. So everything is expressed in what? In SI unit second. That means we are going to convert from this kilometer per hour into meter per second. So how do you do that? So we can write this as 36 kilometer over the hour. So that's what it means. So this can also be written as 36 times 1000, because the kilometer there is 1000 meter. 36 over the hour there is what? 60 times 60. So when you resolve this, the 2 0 cancel 2 0 up, you are left with what? 360. 360 over 6 times is what? 36. So if the 6 cancel this, you are left with what? 1. And our answer is what? 10. So in other words, We can then write that here u is the same thing as what 10 meter per second, which is what 10 meter per second. So remember our time t. Our time t is what? Our time t is given by what 5 seconds. So we have gotten that. So we are going to have v, our u converted from kilometer to what? Meter per second. We are asked to find the retardation. Now, retardation is also known as for negative acceleration. So from v, u, and t. So you can see that from my expression here, we see that v equals what u plus what 80. So so the first equation fits in there. So we have v is equal to what u plus at. U plus what at. But in this case, we are going to have v is equal to u plus bracket minus a, because it's a negative what acceleration is what a negative, and we are talking about retardation. So in this case, we now have here remember, recall putting our values, and because 0 is equal to our u is what 10 plus, we are still interested in a multiplied by time. Our time was given as what 5. Remember, it's minus. So minus 8 times 5, we have here. We now have 0 is equal to what 10. 10 minus 8 times 5 will be what? Minus 5a. Minus 5a. Minus 5a. When you collect like terms, minus 5a crosses from quantity and comes here. We have 5a is equal to what? 10. So we're interested in a. We divide both sides by 5. We have 5a over 5 is equal to what? 10 over 5. So 5 will cancel 5. The other a is equal to what? 2 meter. 10 divided by 5 is 2 meter per second square. So that's it. So we have succeeded in solving for our acceleration. Number 2 said the distance covered during the motion. The distance covered during the motion. So for the distance covered during the motion, so we can use, it's still a retarded motion, right? So we're going to use our equation here now. We have u is given as 10. We have time. The acceleration we have estimated, so we can use So the distance, we are asked to estimate the distance covered during the motion. So from our parameters, v equals to 0, u given, t, and the acceleration we have solved for, so we can write it down. Here we have v equal to what? We have u equals to 10 meter per second from what we have solved for. And also we have t is 5 seconds. T is 5 seconds. Then what is our a we have solved for, which is a is what? 2 meter per second square. So with this one, we can then use the second equation of motion, which says that what s is equal to ut plus half at squared. So substitute here because we're interested in this distance s. S is equal to, since we're interested in distance x, so we put in these values. We have 10 times 2 plus, because 10 times 5. So you go to 10 times 5 plus half times our a. Our a is what? 2 times t is what? 5. 5 then square. 5 square. So we'll continue to solve for x. X equals to 10 times 5 is what? 50. 10 times 5 is 50 plus half 2 times 5. So 2 we cancel 2. You are left with what? 1 as 1. So 1 times 1 times 1. 5 squared is what? 25. So we left what? 50. Remember, s is equal to 50 plus 1 times 1 times 1 is what? 25. So our answer is what? After distance s is equal to what? 75 meters. So that's the solution to the problem on the board as an application for uniformly accelerated motion. With this, we come to the end of this section. Now, if you have questions, don't hesitate to ask a question. You can go to the chat section, raise your questions, and I'll rightly attend to your questions. So we look forward to the next session on more problem based on uniformly accelerated motion. We have come to the end of this session. Share with loved ones, friends, and family. See you in the next session.